The agenda for today's presentation includes the objectives, design overview, data integration, applications, and future work. There are three key objectives for this project. We aim to design a data management system for easily accessible product information, and we aim to improve searchability of products, including product descriptions, product ratings, customer reviews, offers, and inventory tag. Also, we aim to develop some interactive Mongo charts to present the valuable key insights into the database, and also to promote the effective business decision makings. There's no doubt that an efficient product data management system will definitely help the company to organize and regulate the data because it will carry over the data from multiple sources, and it will enhance the customer experience because they can learn about the products from one place. We use the Amazon Movie Product API data as our key data source, and we use those following 5 parameters to call the API and to get the comprehensive product data information. From a bestseller data API, we could get the top 50 bestseller movie products, and for each individual movie product, we got its name information, coupon information, customer reviews, stock level information, as well as offers and sellers information. The data architecture here basically shows the overall workflow of this project. Basically, we use a Python to call the Amazon Movie Product Data APIs, and we save those API JSON files into our local disk. And then we utilize the SSIS as our data integration tool to extract the data from multiple API sources, ensure the data quality, and also transform the data into the target JSON format that match our ERD design. And then we loaded those JSON files directly from the SSIS into our target MongoDB database. Applications for this MongoDB database include the Mongo chart, as well as some special user cases that user can access the data currently stored into our MongoDB database. Moving to the ERD of this project, we choose to use the document database because we use MongoDB as our target platform, and we both utilize the embedding and referencing relationships for the data modeling. As you can see here, for example, for the product document, we embedded the customer reviews information, which include the most critical reviews, most positive reviews into the product document. And because, for one product, it may have multiple offers. Therefore, we use a referencing relationship here, and we put the product ID inside the offers document as a foreign key. And next, Opal is going to talk about more details about the data integration part.
Okay, so the next section here, we'll be talking about data integration on the fun ETL process of the project. As a reminder, we're working with 250 JSON files here, and those files were from 250 different APIs calls. So how would we go about consolidating the data from these different sources into a single data set? Our team decided to use Microsoft Integration Service, or SSIS. This is because the tools offer reusable ETL pipeline with simple but powerful data transformation. This allows us to prevent duplication of data, as well as giving us the ability to capture an audit log by using a staging table. If you look at a little map on the top right corner, that's the overview of the entire workflow of this project. But no worries, we're going over only a tiny section of this as an example. So at the bottom left, we started with loading the raw data from JSON file into one big staging table. Then the data in the staging table was cleaned, converted to a desired data type, and then loaded into a temp table in SSMS. In this process, primary keys were generated, and these keys were also added back to the staging table. So how did we prevent duplication of information when we assign a primary key to a new data? Here you can see from the call out on the right that we use a lookup tools in SSIS to check if the data points already exist in the database. If the data is truly new, it gets assigned a primary key while being added to the theme table. Next slide. Thank you. Now we repeated this process for every table until we arrive at the final step. The additional tool we're using here allows us to design a JSON document, then embedded some data to it. And finally, loaded the JSON document directly from SSIS to MongoDB Atlas, which is the cloud service of MongoDB. Next slide. Now let's take a quick look at the data that is now in Atlas. As you can see, we have 4 different collections of data in total: bestseller, inventory, products, and offers. And the picture on the right-hand side, that's an example of the document with layer of embedded data. Okay, now that all the data is in the database, my teammate Machen will show you how we made use of the data.
Thanks. Here we have some visualizations from MongoDB chart. First, we have the example for bestseller number 10. The histogram on the left is the price from all offers, and the table on the right shows the offer information such as seller name, offer price, and seller rating. Next, please. The donut chart shows the number of rating 1 to 5 stars of bestseller number 1, and the table at the right shows the percentage of the rating for all products. Next, please. Now, we have the histogram to show the comparison of the average offer price and recommended retail price for top 10 products. Next, please. From this table, we can get the product information for all top 50 bestsellers from product review and inventory data. Next, please. Let's talk about the user cases. We have 7 user cases for product information, offers, and inventory management. Next, please. First, we have the overview product information. Users can get product information such as product ID, product name, rating, reviews, average offer price of each product. From the results snapshot, we can see all the information and even the most positive reviews and most negative reviews here. Next, please. Second, we have the rating scores of individual product. The result shows both number of ratings and overall percentage for all levels of ratings. For example, here, product ID 1 has rating score 4 with 883 reviews in total, and following with more details. Next, please. Product's top 3 offers overview shows the product information and the top 3 offer with seller information. Here we have product ID 1 as example, sorting offer price by ascending order. Next, please. Products offer and conditions shows the product information such as product ID and title with all the offer price and conditions, also sorting offer price by ascending orders. Next, please. Next, we have products offer price, summarizing the average offer price of the 50 bestsellers. Next. For the inventory management, we have all the products inventory information such as inventory ID, current inventory amount, and status. Users can easily check the inventory for the product. Next slide. Finally, we have the low inventory check, which shows all the products with less than a specific number in the inventory. In the example, we check all products which has less than 10 units. Next, please. For the future work, we can create triggers such as email or text notification to automate restocking based on predefined business rules. We need replica database to capture the audit trail to be able to create the trigger. We don't have the replica in the current account, so we cannot create here. Second, we can promote cross-selling and upselling by capturing also bought details for each product through Amazon recommendation system. Moreover, we can create archive table for all information and include timestamp for data integration. Okay, this concludes our presentation. Thank you. Any question?
So just one question, how do you go about cleaning this all the source files, because you said that you had to use a lot of source files. So how did you clean all the data?
Yeah, that's a really good question. So that's Actually, the reason we picked to do the ETL in SSIS, because, it's, a pretty powerful and easy tool to use. You build one ETL pipeline, and then, we had the initial workflow for the first file, pretty much, sorry, I mean, the first product. And then we have another control flow that we would use to add another product. And like I mentioned in my slide, I use the, we use the lookup transformation tool just to make sure we did not capture any duplicate product. So yeah, after we ran the first product into the database, then the rest, like the 49 products after that, we just use the update control flow to run that. So that's how we were able to, process all the massive file. Did that answer your question?
Yeah. Thank you.
Yeah. Any other questions?
Excellent work and the presentation end to end from team 5. And I have a question for team 5. How did you integrate SSIS with MongoDB?
Yeah. So we were, well, first of all, we converted, we converted JSON document into a relational database table. Sorry, just lost of word. And then we were able to put, all the data back into JSON document using this additional tools that actually didn't come with the SSIS package originally. So the company that we got the tools from is called SSIS. So they have this tool that would convert relational database table into JSON document. And the really cool thing is that we could actually design the JSON document into whatever format we like, including embedding data. And then from that, we can transfer the data or load the data directly from SSIS into MongoDB Atlas.
So that's so you installed an add-on, so to speak.
Correct.
And what's the name of that add-on? Can you repeat that?
Yeah, so the company name is, and it's also pretty much the name of the tool, it's Zappy, ZAPPY, and SYS, SYS.
Excellent. Excellent. Because SSIS has been widely used in the industry, but usually we use SSIS with relational databases. That certainly has expanded the functionality of SSIS to work with non-relational databases. So thank you very much for the great work and presentation end to end.
Thank you.
And thank you for the question.
Thank you.
Thank you.